We're working with piecewise and greatest integer functions, and we want to be able to graph piecewise functions and write piecewise functions from a graph. Whenever I'm working with a piecewise function, like we have h of x here, I always look at the restrictions on the domain. And in this case, our restrictions are only -4. So I'm going to go ahead and graph that on the line to remind myself where those restrictions happen. So this is going to be x is equal to -4. So I'll take a look at the first one, and we have x is less than -4. So a value less than -4 I could pick out would be -5. So we'll evaluate h of -5 because that is less than -4. And we'll say that's equal to the absolute value of -5 minus 3. So then we have 5 minus 3. And so that is going to be equal to 5 minus 3 is 2. So we have the ordered pair -5, 2. So we have to set up our grid here. So -5 this way, -5 this way, 5 this way, and 5 this way. So -5, 2 is right there. And we know that our slope is +1. So from our vertex of the absolute value function, the vertex for this function will be at 0, -3. So 0, -3. That would be down there, but we can't graph it because it's inside the restricted domain. So we can only graph to the line that's to the left. So because the slope is +1, we go up 1 and to the right. And we also do that to the left. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Now, as we look at the inequality sign, we have x is less than -4. So this point is not included. So we're not going to include that one. And then we can go up 1 over 1. And then we have that. So then I can plot this graph here. We knew that the point was -5, 2, and then that was absolute value function, and then we're able to get our graph there. The next one that we can look at is, it says, for the restriction on the domain, it says only when x is equal to -4. So it says only when x is equal to -4. So we can substitute that value in, and we can say h of x, in this case, we're talking about h of -4 because it's only when it's equal to -4. And that is going to be equal to negative multiplied by -4 minus 4. Negative times negative is positive, so that's 4 minus 4. And so that is going to be equal to 0. So then we get the ordered pair -4, 0. So -4, 0. And in this case, it's equal to, so we'll use a closed dot at -4, 0. And then the last part of the domain, this is when x is greater than -4. So any value that's greater than -4. And a good one to pick for that, we can always pick 0. I'm going to pick -1 in this case. So we want to evaluate the function h of x when x is equal to -1. So -2 times -1 minus 2. And so that's going to be equal to -2 times -1 is +2 minus 2. So that's going to be equal to 0. So we get the ordered pair of -1, 0. So -1, 0 is right there. Then we take a look at our slope. Our slope is down 2 over 1. So down 2 over 1, down 2 over 1, and we got to go the other way. Up 2, back 1, up 2, back 1, and then we're a little bit off the graph here. Up 2, back 1, and this one is not included, so we'll use an open circle there to make sure that that is not included. And then we'll draw the line that goes between all those points, but does not include that first one. And that's what the piecewise function will look like. This is the function h of x is equal to negative 2x minus 2. That's that one. And then we have the function right there where that one is equal to h of x equals to x minus 4. And then we have h of x is equal to the absolute value of x minus 3, which is right there.